Welcome back. Let's practice translating verbal expressions into variable expressions. Alright, so here's our first set of examples. Starting with this verbal expression, we have the sum of 2 and x. Alright, and so the key word or phrase that stands out in this sentence or in this verbal expression is the phrase the sum of. That refers to the addition of two numbers. In this case, the sum of 2 and x. Alright, the two numbers that you are adding together are separated by that word and. Alright, so the sum of refers to the addition of two numbers, that being 2 and x. So we would have 2 plus x. Or if you wanted to, you could also write it like this. You could also have x plus 2 because the order of addition does not matter. But either way, that would be the right answer for the variable expression that this verbal expression represents. Moving on to our second example, we have 9 decreased by y. And the phrase that stands out this time is this phrase, decreased by. When you see the words decreased by, that is referring to subtraction. We are subtracting y from 9, right? 9 decreased by, or you could read it as 9 minus y. Okay, so decreased by refers to the operation of subtraction, and we have 9 minus y. 9 is being decreased by y in this expression, so that is what this verbal expression represents. Let's look at some more examples. Next up, we have 10 times a number. In this case, notice that the variable or the unknown number that would be in this variable expression is not given to us explicitly. It's just referred to as a number. So we have the choice to let that number be represented by any variable we'd like. We can use any letter we want to represent that number. I'm just going to choose to use the letter n. So let me write that down here. We're going to let that number be represented by n, okay? And so if we have 10 times that number, times is referring to multiplication, so you could write it as 10 dot, that dot refers to multiplication, so 10 times n, or you could just write it without the dot, and that would mean the same thing. That would be equal to 10n, which represents 10 multiplied by that number that we are representing with n. That is the variable expression represented by this verbal expression. Moving on to our next example, we have the quotient of a number and 8. Okay, so the quotient of refers to dividing a number by another number. In this case, our two values, or two numbers that we're working with, are some unknown number and 8. All right, so once again, I'm going to let a number be represented by n. And so if we have the quotient of that number and 8, I'm going to write a division bar or fraction bar, and we'll have that number of n in the numerator or the top of the fraction, and then 8 in the denominator or the bottom of that fraction. Okay, when you have the quotient of some number and another number, the first number goes in the top of the fraction or on top of the division bar, and the second number goes in the bottom. All right, so that would be the variable expression represented by this verbal expression. Next up, we have the product of 3 and the square of x. Okay, so our sentences are getting a little bit more complicated now. We're not just working with one mathematical operation. Notice in this sentence that two different operations were mentioned. We have the product of 3 and the square of x. Okay, so my recommendation here is to break it up into pieces. Look at the first phrase or the first operation that you see. In this case, that is this phrase, the product of. The product of refers to the multiplication of two numbers. All right, the result of multiplying two numbers gives us a result that we call the product. So the product of refers to multiplying two values that will come after that phrase. And those two values will be separated by the word and that word and is right here. So we have the product of 3 and the square of x. Okay, so we are multiplying. Let me draw a little dot for multiplication. And we are multiplying 3, so let's put 3 in front, and the square of x. And the square is referring to taking that value of x, or that variable of x, to the power of 2. All right, so we would be multiplying 3 by x squared. And you could write this a little bit simpler. You don't have to write that multiplication sign. If you just write 3x squared, the multiplication between 3 and x squared is implied. All right, so that right there would be the variable expression represented by this verbal expression. Then going down here, things are getting a little bit more complicated. We have the total of twice a number and 12 multiplied by the number. All right, so now we're going back to not knowing what our variable is. We have to assign a variable to our unknown number. Right up here, we were given that it is x, but in this case, we're just referring to it as a number, right? The total of twice a number and 12 multiplied by the number. So in this case, I'm going to assign the variable of n to that number. So let that be n. And then to actually write out the variable expression here, there is a lot going on in this sentence, but just start with the first phrase that you see. In this case, that is the total of. All right, the total of refers to addition. When you add numbers together, you could refer to that as the total of those numbers. All right, so we know that we are working with addition, so I'll write down a plus sign, and the two values that we are adding together will be separated by the word and that word is right here. So the two things that we are adding are twice a number and 12 multiplied by the number. So starting with this one, twice a number, the word twice refers to 2, specifically the multiplication of 2. So when you have twice a number that we're representing with n, that is referring to 2 times n. You could write a little dot for multiplication, but just writing 2 next to the variable of n implies multiplication. All right, so that's the first number that is involved in this addition, but then the second number is 12 multiplied by the number. All right, and so this is very clearly referring to multiplication. We're multiplying 12 by this unknown number that we are representing with n. So we have 2n plus 12n. Okay, and that's it. That would be the variable expression that represents this verbal expression, but do notice that you could simplify this. 2n and 12n are both like terms. They have the same variable part of n, so you could add their coefficients. So a simplified form of this answer would be 14n. That would be another possible answer if you needed to simplify your result. But if you just need to write out the variable expression that is literally described by the sentence, then you could stop here. But I just want to point out that you could simplify it since they are like terms. Okay, let's look at another example. Hey there, real quick, before we take a look at the next example, if you find my tutorial videos here at JK Math to be helpful, then I'd like to invite you to join my membership site, JK Math Plus, where you get access to many perks, including bonus content and my exclusive community. The bonus content includes dark mode versions of my videos, extra example problems, and more, while the community is a private space online where you can post questions, have discussions, and study together with me and other members. To learn how to join and see a full list of everything you get access to as a member, you can head over to jkmathematics.com/plus. I'll have a link for that in the description of this video. So if you are interested in becoming a member, feel free to check that out. It's a great way to support me and the tutorials I make, as well as a great way for you to learn math better. But for now, let's take a look at the next example. Here we once again want to translate the verbal expression into a variable expression, and we have the difference between 4 less than a number and the number increased by 11. All right, so there's a lot going on here, but just break it down into pieces. Start by identifying the first phrase that refers to a mathematical operation. In this case, that would be the difference between. That phrase, the difference between, refers to subtraction. So we are going to be subtracting two numbers. In particular, those two numbers should be separated in the sentence by the word and. And so looking at our sentence here, the difference between 4 less than a number and the number increased by 11. So that and separates the two numbers that we are subtracting. Let's start with the first one here, 4 less than a number. The phrase less than also refers to subtraction. All right, so our first number here will be in a set of parentheses because we are going to be subtracting two numbers and then subtracting something else. And in this case, we have 4 less than a number. So we do need to assign a variable to that number. Again, I'm just going to call it n. And so 4 less than a number translates to that number of n minus 4, okay? Whenever you see that word then paired with the word less, that means that the number that is listed first is subtracted from the second, okay? 4 less than a number would be that number minus 4. And so that is the first value on this side of the subtraction sign. but we are taking the difference between that value and another value, specifically the number increased by 11. So once again, the number refers to that variable of n that I assigned to the number before. All right, it's the same number, and we are increasing it by 11, and that phrase increased by refers to addition. All right, so in this case, we have the addition of two numbers, specifically that number n and 11. And that right there would be the variable expression translated from this verbal expression. And I'll just rewrite it here to be one solid color. We have n minus 4 in parentheses minus n plus 11. That would be the correct answer. But just like one of our previous examples, notice that you could simplify this variable expression. You could distribute this negative through this quantity and then combine like terms, right? Let me just show you that real quick. We would have n minus 4, and then distributing that negative through this quantity results in changing the sign of both of these terms. So you'd have minus n and minus 11. And then from there, notice that you have a positive n and a negative n. Those cancel each other out. N minus n would be equal to 0. And then you can just combine your like terms, in this case two constants, negative 4 and negative 11. Those two numbers combined give you negative 15. So negative 15 would be the fully simplified value resulting from the variable expression that we translated from the verbal expression. And so if you were told to also simplify, this would be the right answer. But again, if you just need to literally translate the verbal expression into a variable expression, this would be correct as well. Okay, let's take a look at another example. This time we have the quotient of 6 and the difference of 1 and a number. All right, so breaking this apart piece by piece, start with the first operation that you see. In this case, we have the phrase of the quotient of, which refers to division. So we are going to be dividing two numbers. So I will draw a division bar. And after that phrase of the quotient of will be two different numbers separated by the word and. But now there are two ands in this sentence. And so you have to use a little bit of context clues or a little bit of intuition to figure out which and is paired with the quotient of. So if we read the sentence again, it says the quotient of 6 and the difference of 1 and a number. Okay, so I think it's very clear that that first and would be paired with the quotient of. And so the two numbers that we are dividing here would be 6 and then the difference of 1 and a number. So 6 is the easier one to recognize. We're just going to have 6 in the numerator. But then what about the denominator, or the bottom of the fraction? It will be the difference of 1 and a number. The difference refers to subtraction. All right, so the difference means that we are going to be subtracting two numbers. And so what two numbers are we subtracting? Or what two numbers are we taking the difference of? Well, we're taking the difference of 1 and a number. So we have 1 and then some number that we need to represent with a variable. I'll just use the letter n once again. And so that right there would be the variable expression. I'll write it again in one solid color. We have 6 divided by 1 minus n. That is the variable expression represented by this verbal expression. For our next example, we have this verbal expression, the product of the sum of a number and 7 and the number less 7. Okay, so this one seems a little bit complicated at first, but remember, just try to break it up piece by piece, starting with the first operation that is mentioned. In this case, the product of. All right, the product of refers to the multiplication of two numbers. And so what are we multiplying? Well, those two numbers are going to be separated by the word and. But we have to be careful here. There are two ands in this sentence, right? We have the sum of a number and 7 and the number less 7. So how do we decipher this? How do we determine what two numbers we are multiplying together? Well, once again, you have to use a little bit of intuition or a little bit of context clues. If you look at the next phrase after the product of, it says the sum of. All right, so that means we're adding two numbers. So that probably means that the next and will be connecting the two numbers that we are adding together because we are taking the product of a sum with something else. All right, so first of all, let me just write down a multiplication sign here, or a little dot, and then we're multiplying that by the sum of a number and 7, okay? So those are the two numbers being added together. We have the sum of a number and 7. And so since we are going to be multiplying that sum by something else, I am going to put them in parentheses. So we have the addition of two numbers, specifically a number that we can represent with the letter n. So we have n and 7. So we have n plus 7 multiplied by something else. And that other number, or that other value that we will be multiplying by, will be followed by this and, which we now know corresponds to the product of. Okay, so we have the product of this value and this value. In this case, the number less 7. And so the phrase less refers to subtraction. So once again, we need to pull out a set of parentheses because we are going to be subtracting two numbers and then multiplying that by the other value. In this case, we have the number less 7. And notice that the word than is not there, right? It's not the number less than 7. It's just the number less 7. So you could translate that to be the number minus 7. So you would have that number of n minus 7. All right, and that's it. You could rewrite this. You don't need that little dot in between those two quantities. If you just write them next to each other, that implies multiplication. So this would be equal to n plus 7 times n minus 7. All right, that would be the variable expression that this verbal expression represents. Next up, we want to translate this verbal expression, the difference of 1/3 of a number and the total of the number cubed and 9. All right, so let's break it up piece by piece. The first operation that I see is referenced here is the difference of. That is referring to subtraction. So we are subtracting two numbers. So I'll write down a subtraction sign. But what are we subtracting? Those two numbers should be separated by the word and. The first number here is 1/3 of a number, and then there's the and, okay? So that and is what pairs up with the difference of. So we're going to be taking this value minus whatever is after that and. So we have the difference of 1/3 of a number. Let's just let that number be represented by n again. So 1/3 of a number is referring to the multiplication of the fraction of 1/3 by that number. All right, we would represent that with 1/3 times n. Okay, that's what that phrase there means, 1/3 of. If you see the name of a fraction like 1/3 or 1/2 or 1/4, and then the word of, that means that you are multiplying that fraction by whatever follows it. In this case, a number. All right, so we have the difference of 1/3 of a number, which we have right here, 1/3 n, and the total of the number cubed and 9. So now we have another operation. We're taking the difference of this value and the total of. The total of refers to addition. So we're not just subtracting a single value, we're subtracting the addition of two values. So I'm going to put in some parentheses here. Specifically, we have the addition of the number cubed and 9. So the number, we're representing that with n. When it says the number is cubed, that means that we are raising it to the power of 3. That's what that phrase or that word means. So we have n cubed, or n to the power of 3, and we're adding it to 9. All right, n cubed plus 9. So the total of the number cubed and 9 is right here. Okay, that and separates the two numbers that we're adding together that go in that quantity. And that's it. That would be the variable expression represented by this verbal expression. I could rewrite it here. We'd have 1/3 n minus n cubed plus 9 in parentheses. And if you wanted to, you could simplify further by distributing that negative through this quantity. It would just change the sign of both of these terms. So while this would be the correct answer here of what this verbal expression represents, you could also rewrite it or simplify it to be 1/3 n minus n cubed minus 9. All right, you could distribute that negative through the quantity. Okay, but either way, both of those answers would be correct. Okay, let's take a look at one more example for this video. All right, so here's our last example. We want to translate this verbal expression into a variable expression. It says the quotient of 8 times a number and 10 more than the number squared. All right, so once again, let's look for the first operation that is mentioned. In this case, that is the quotient of. That is referring to division. Remember that the division of two numbers results in a value that we call the quotient. So I'm going to draw a fraction bar here. Clearly, we are going to be dividing two values. And so let's see what they are. The two values should be separated by the word and there's only one in this sentence, so that makes it pretty easy. This and right here separates the two numbers that we are going to be dividing. In this case, the first number which goes in the numerator or the top of the fraction, is 8 times a number. All right, times refers to multiplication. We're going to be multiplying 8 by some number that I'll represent with n once again. So 8 times a number would be represented by 8n. And then in the denominator, or the bottom of the fraction, we will have whatever this part of the sentence represents. So we have 10 more than the number squared. And the key phrase to look at here is more than. All right, we have 10 more than the number squared. More than refers to addition. And specifically that word than means that the number in front is going to be second. All right, we have 10 more than the number squared. So the number squared would be that variable of n to the power of 2, right? Squaring a number, or a number squared, refers to taking that number to the power of 2. So that is what would go first. Remember, we're adding two numbers. N squared will go first, and then we're adding 10. All right, 10 more than that number squared. So you take that number squared and you add 10. All right, and that would be the variable expression represented by this sentence or this verbal expression. Okay, so just to rewrite it as one color here, 8n divided by n squared plus 10 is our final answer, and so I'll box it in. Okay, and so with that, that is it for this example. And this was also the last example for this video, but if you do want to get some more practice translating verbal expressions into variable expressions, I do have more available on my membership site, so if that's something that interests you, feel free to look into becoming a member. You can find all the details on my website at jkmathematics.com/plus, and I'll have a link for that in the description of this video. If you have any questions, please let me know in the comments, but if you don't have any questions, this is all I have for now. So I will see you next time.